C++. When I mean it's has access, the components which are used in the chips which are developed, we can easily access those components. They provide APIs, the C++ APIs, so we can easily access those components. Similarly, embedded systems, the graphics and games and medical engineering applications where you use that MRI and all, those are all developed in C++. And the web browsers like Internet Explorer and Chrome, the inbuilt language in those is used again is C++. So those are the use cases which we discussed. But why C++ is the first factor, the main important factor is performance, scalability, control, and portability, right? So, for example, what is scalability, right? Uh, any component where you do something, it's not only handling the request responses, but it should be the program you write should be scalable. So, a real-time example of scalable is so the same program is accessed by multiple users at a time. For example, let's take Facebook, right? So if you are going to the web browser and if you are clicking on Facebook, it's opening, right? Assume same time there are 100 users opens Facebook, right? The same page is getting open to everyone, but the program is still supporting you, right? So at a time, 100 people are able to access Facebook application. Assume what if 100,000 people or 1 lakh or 2 lakh people access the same Facebook application. Facebook application should not be slow, right? So because if it is slow, users will not use it anymore, right? So assume for Facebook that for every minute there will be millions of users who access Facebook application. So in the back office where Facebook application is deployed, the application needs to handle various load, which means various users at a time, right? So the application needs to be scalable. So that's what is scalable meaning. Okay, it's very high level for you, but just for understanding purpose, like why we are using, I'm just telling you. So portability. So portability means when you write a program, assume in your class itself, few people are using Apple phones and few people are using Samsung or some Android phone, right? So Apple phone runs on Mac OS operating system, whereas Samsung runs on Android operating system. Laptops run on Windows operating system, or your laptops may run on Linux operating system. So the operating systems are always different here. So you don't keep on writing one program for each place. For example, if I'm writing a program, I won't write one program for Apple. I won't write one program for if you need to write one program for every operating system, it will be hard to, the development will be harder, right? The same application you need to develop in multiple operating systems because there are multiple kind of users. So instead, if you use C++, write program once. Whatever the program which runs for you, that program is portable, which means that program can run on your Apple operating system, or it can go to Linux or Windows operating system. So that's what is portability means. Okay. One other reason for C++ used in apps and everything is it has access to hardware systems. So the hardware systems are the embedded systems which are built in your mobile phones or laptops and everything. They provide an interface. Hey, if you give me this kind of input, I will give you this kind of output. So those interfaces are accessible to C++. So when you are, for example, uh, you are developing an assume in your app which is in your mobile phone. So if your mobile phone hardware, for example, your mobile phone is 20 GB in your phone, and if your game needs 30 GB, it should crash your mobile phone, right? The app, if it's trying to install, it should check what is the minimum requirements it is required, your phone requirements. So the product plus can easily access your resources in your mobile phone, and you can know how much power it has, your phone has, how much GB it has, or how much space it has, whether it can pull lat-long from the phone, location of the phone. So there are various factors which a mobile phone has, right? So the program, while doing in C++, you can easily access your low-level hardware systems also. So one other advantage, and another one is performance. The C++ is very efficient language, so which means the performance is very faster. So, for example, if you have a program uh, using C++, it may run in 20 milliseconds. So if it is running in 2 minutes or 3 minutes in some other programming language, C++ can optimize it, and it can be very faster. So the C++ programs are running is very faster, and it has control, uh, like what resources to use, or whether it should be performance, or it's relating to the enterprise applications. So you'll know more in the future. So I think this one we discussed already, the major principles of OOPS concepts. We'll be detailedly going about this, about data abstraction, encapsulation, information hiding, polymorphism, and inheritance. So, so like last week we discussed. So let's take an example of a game. So when we are designing the game in an object-oriented programming, the advantage of doing this in an object-oriented programming. So assume you have for a game you have different players. So while if you are designing for a game, how easily you can design in object-oriented programming concepts, right? So what do you have in a game? You have players, right? So when you mean player here, what are the characteristics of player here? A player has a number. A player may have a name, his age, his how much weight he is, what is his height. So these are characteristics of player. So you can easily separate a player. Similarly, for a game, you have audience. So what are the audience and what are the characteristics of audience? So while playing a game, what is the weather conditions? So because every minute the weather changes, so how is the weather? So how many balls and everything. And similarly, what field it is. What about the referee? How is the scoreboard? So you can separately, in the object-oriented programming, when you are building an application, you can visualize it actual scenarios, and you can separate them. So while writing the program, it will be easier for you because you are tackling the real time situations here. So while writing the classes, you can write the classes according to your game. So that way the programming will be very easier for us, right? Last time I was explaining you about your college. So in terms of classes in your college education, you can say a student is one class. Similarly, faculties will be one class. Uh, College will be another class. You guys are paying fees and everything, so billing will be one class. They maintain attendance. So attendance is one class. So in that way, if you are writing a program for your college, you can have your class names similar to your real world examples. So I wanted to ask you a question like in your lab programming, if you want to run a C++, what software do you use? Like, I don't know, can you install a new software in your lab or do you already have some software to run C++ programs? Can any one of you answer the questions?
Any one of you can unmute yourself and answer it. Harsh, Sanjeev, any one of you can unmute yourself and answer it.
Ma'am, we are using code blocks and Dev C++.
Sorry, what is it?
Anil, they are using Dev C++
And code blocks.
and code blocks.
Code blocks. Okay, after the class, before next class, I'll see what is the code block here. So for running the C++ program, you need C++ libraries. So what is mean by a library, right? So for doing C++ programming, the C++ has already given us some classes. So for example, if you want to print a statement, they already gave a function for it. If you want to do size set, or if you want to do a length, so there are some libraries are already available. So when we are writing a program, we need access to those libraries, and our program will be running on C++ compiler. So that is the reason we need the C++ library to run our programs. So in general, I mean, we have Microsoft Visual Studio where we can install in our laptops or your college computers, CMate, and there are many other IDEs available. So when you mean IDE, so in olden days, like very long back, when we are writing a program, we used to write the program in Notepad, the general Notepad. We write the program in the Notepad, then we compile it, and then we use some other techniques to run the program. So we didn't have the hi-fi coloring, line, length, streams, and everything. So later, what happened is when the software got evolved, we got IDEs. So when you mean an IDE is, for example, to do a new class, it will automatically show you a button. If you click on that new, it will open a new class. You can import the libraries. If there is an issue in the line, any line, it will clearly show you what is the error in that line. So the IDEs makes our lives easier to do the development of a program, to run the program, or to debug the program. The IDEs are very much helpful. So, whatever you are using CodeBlur, let me see, and I will try to use the same CodeBlur so that it will be easy for you also to understand instead of me using one other editor. So let me see how is this CodeBlur. Like already we discussed last time, I guess. So a class, right? So we already discussed about what is a class and what is the object, right? So for example, for your class student, int ID, string name, and string branch. So when we mean for student, for your class, there will be each student has an ID, name, branch. Similarly, you guys may have a phone number because individual, everyone has a different phone number. So one more characteristics of student will be a phone number here. You may have your address, like a street, city, zip code. So when we are writing a program on student, it's very easy to represent a class on student. So an object. So for example, in your class, there are 60 students or 100 students. So similarly for that class, we can easily create an object. So an object is nothing but which has data and behavior. So for example, if you see this class here, the class level variables are ID, name, and branch. So for student S1, ID will be different. Let's take this object example. So here for class student S1 and student S2. For example, this S1 and S2 are objects. So for S1, I have a different data. For student S1, ID is 100, name is Alex, and branch is computer science. So similarly for object S2, I have ID as student ID as 101, name as John, and branch as computer science. So now I have two objects for same class, student S1 and student S2. But now S1 has its own data and S2 has its own data. So that's why we say an object is an entity that encapsulates data and behavior. So where behavior is a set of functions or methods that operates on the data. So for example, here if I have a method in this saying get student marks or get student rank. So based on the ID, that method will return a different rank for each student. So that's the behavior. So the data is different. The data is for each object. The data is different, and similarly for each object, the behavior is different here. So that's why both of the objects S1 and S2 will have their own copy of data members. So S1 has its own copy, S2 has its own copy. So when I say when I assign the values for this S1, it will have its own copy, and when I assign values for S2, it will have its own copy. So for this student, for example, in your class there are 60 students, then we'll be having 60 objects. So if I want to change the behavior for one student, I can easily change the behavior because I'm not doing anything here. For each student, I'm changing separately. So it's very easy to map to the real world situation. So that is the beauty of object-oriented programming. So that's why a class is a template for object creation. It contains the complete definition of any object that is created from it. When we create an object from a class, we say we instantiate the class. So when we say object of a class or when we say instantiation of a class, both are same. So for the tar, I already discussed the last time. So let's take this example here for a student. So here I'm saying ID, name, branch, and I'm just writing a simple program here. Student S1, student S2, and I'm saying S1.ID 5, or I'm assigning values to student S1, and I am assigning values to student S2, So for S1, I'm giving an ID, I'm giving the values as 5, Alex and CSC. And for object S2, I'm giving the values as 6, John and CSC. And I'm using the cout. Cout is nothing but C++ has given a way when we run the program. They gave us a way to print the uh, print the line. So when this line number 25 is executed, what cout does is it will print whatever is in the code, student S1 details, and it will try to get the value of S1 ID, S1 name, and S1 branch. So when we run this program, the values will be printed on the console. So if you want to print something to the console, we use cout. So cout is nothing but it's a library provided by C++. So it's a inbuilt. So we don't need to know. All we need to know is why to use cout. So we do something to cout, it will print on the console. So that is the cout here. So are you able to see? So here I'm using a simple editor. So for example, if I execute this program, here I'm saying hello world. It's just coming to the main and cout and hello world. So if I run this program, it's just printing me hello world. So now let's understand what is this hash include, right? So here what we are trying to tell to the compiler is get this library iostream. So I'm telling this program have iostream library, get this library because I'm going to use this library. So an include keyword is nothing but it tells what all the libraries to use from C++ to the C++ compiler. So for example, when you may write this program, but you need a compiler to understand it. Because, for example, if you go to China, you may need a translator. If you speak in English and a Chinese person cannot understand your language, right? So generally we have a translator. So there will be one guy who knows your English language or your native language and who knows Chinese language. So when you ask him something, he will translate it and he will talk to the Chinese person. Similarly, when Chinese person gives the response, he will again translate it back to the English and he will again answer it. So similarly, when you write the program, if you put it somewhere and just run it, it cannot run. You need a compiler to understand what you wrote, right? So for that, they gave that language. So if you go and write there, hey, I am here, the compiler will not understand because C++ has its own language. So you need to talk to the C++ in the language it provided to us. So for that, C++, we will be using the compiler to compile your program. So when it compiles your program, you are telling the compiler you have this library because you are going to use this library in your program. So for example, in your C++ library, there may be thousands of libraries. You cannot import all the libraries into your program because your program will become heavier, right? For example, now if I am taking this and putting it into an app and having it in your Android or iPhone, and if anything you click on your app, all it should just show is hello world. So when this program is exported and put it into an app, and installed on your app, you guys would have already always observed something like when someone says, hey, this app is very good, go and use it. You guys go and check what is the size of the app, right? If it is more than 20 MB or 50 MB, you don't generally install it because it is using a lot of your space, your mobile space, right? So when this program is exported and it needs to run somewhere, it needs some libraries along with it. So generally, whatever the libraries you need to your program, you only include those libraries. So and let's see this main here, right? So what is a main method? So when I say run this program, there should be some way your C++ compiler should know where to start, right? So, for example, when faculty comes to the class and when he starts attendance, he doesn't go zigzag fashion like 98, 97. He goes from number 1, right? He knows where to start for the attendance. So similarly, when this program is running, the program has 1 to 19 lines here in this example. How does compiler know where to start? Like, should it start here? Should it start here? Should it start in the line number 15? So compiler doesn't know to run the program. It needs to know where to start. So what C++ intelligently did is gave us an inbuilt method, which is a main method. So if you want a program to run, if you put main method, and when you run the program, the line number 13, the program will start from line number 13. So that is the reason it starts from here. And then here in the first line, I am saying is I'm opening the braces here. So when I open here, you need to close the program. So this is a proper programming fashion, like where you are saying start the program here, and this method main is also a method. So it starts here and it is ending here. And in the line number 15, I'm saying cout and I'm saying hello world. So all I'm doing is I'm providing some statement to cout and I'm asking it to print. So already I told you cout is nothing but it's a given by C++ to us. If you want to print something onto the console, use cout. So here console is nothing but this one. So here this is all console here. I'm asking something to print on the console. So here it is printing hello world. And here I'm saying return 0. Because for this main method, a method needs to have a return type. So here I'm saying return 0. And already I'm telling the main method I'm going to return an int, which is this 0. So as once we go more into the programming, we'll have more understanding on this. So okay. So now let's see the student example which we saw earlier. So now what we did? So class student, I'm saying int ID here. For ID. Okay, let's see later that one name and branch. And to execute this program, I have a main method, and I'm saying student S1, student S2, and I'm assigning details for my objects. So now I have two objects, S1 object and S2 object, and for S1 I'm giving ID as 5, name as Alex, and the branch as CFC, and I am printing them here in the line number 25, student S1 details, S1 ID, name, and branch. Similarly, I created an object S2, and I have I assigned some data to the object S2, which is 6 John and CSC. So For initial understanding purpose, I am using cout here. Later we'll see more programming on this. But why we are using cout is used very easily to see whether our program is properly running. For example, let me remove these statements, and if I run this program, I don't know what happened in this program, right? So generally, to debug the statements, we write some cout so that we know what happened in the program. So, for example, if I put those statements here, and here I'm saying print once this program is executed, it will start assigning the student S1, S2, and it will assign these values, and then it I'm printing those ID, name, and branch. So now let me execute this program. I'm printing student S1 details, 5 Alex and CSC, and I'm printing the student S2 details, 6 John and CSC, right? So let's see what was the first statement executed here, right? So I'll put here now see, I hope you're able to see the down screen also here, right? So see the compilation failed due to the following errors. In function int main, line number 13, error, S1 was not declared in the scope. If I click on this line number 13, this is the line number 13, right? So which means program started from here. Or for more understanding, I'll just read this one more time. It's not even compiling. See here, the reason why it is giving an error, I don't want to show this first here. Okay. So first it went to start main, and then it got objects created, and then it printed S1 and S2, right? So now instead of printing cout here, I'll take this cout and put it here, and then run the program again. So it is saying the line number 14 has an issue because it's not able to know what is this S1 here, right? The reason is S1, an object is created in line number 16. But in the line number 14 itself, we are trying to access S1. So that is the reason it is saying it doesn't know where is the S1 here. S1 was not declared. Because in the line number 16, S1 is declared. So when the program starts executed, first it went to line number 11 because C++ knows where to start in the main method. Then it will go to line number 13. There is no problem here. Then it goes to line number 14. Once it goes here, it sees s1.id and it doesn't know what is s1 here. But after line number 14, you have in the line number 16, S1 object is created, right? So, but line number 14 doesn't know what is S1 here. So that's why you need to first declare, use the variable, and then you need to start using the variable in the program. So similarly, instead of ID, let me say here as a student ID, but here I gave it as ID, right? But the variable name I am giving it as student ID. Now it is saying line number 19, class student has no member name ID, and student S2 it doesn't know ID. So it is giving all the errors because it doesn't know what is this ID. So how does S1 knows what are the variables? Because the student has variable student ID, name and branch, right? See this class here. So this class student has variables ID, name and branch, right? So in object S1, if I try to access S1.id, it says S1 doesn't have an ID because it's not able to. So the objects can access this fields. So a student object can access only these fields. Whereas here we are saying s1.id, right? So access modifiers, a class member can be defined as public, private or protected. By default, members would be assumed as private. So let me go back to the. So here, if you see, we are giving access specifier as public. So what is access specifier? So when a class has variables called ID, name and branch, I can give access like whether it should be a public variable, whether it should be a private variable or it should be a protected variable. A simple example would be when you log into your Facebook, you have a friends, right? You can have public friends, you can have private friends, you can have like when you do a post, you can choose like this post should be visible only to my friends, or the photos you share, it should be only visible to the friends who are only in your circle, right? The advertisements or whether it can be visible to everyone, whether whatever you like. So it's all about access, right? So similarly, for the class variables, whatever we have, it has access levels, whether it can be public or private or protected, right? Uh, Also, we have types. So let's come to the types here. So for example, int. So when you have a number, simple example, simple type would be int because it's an integer variable, integer field. So you give it as int. So similarly here, as a name will be a field with characters. So we are telling this as a string. So similarly, branch is a computer science. I'm telling this as a string. So so to access the data members, if you don't want someone to access your data members, you will be giving them as private, so that you don't want anyone else to access your variables other than uh, other than your program. So if you want anybody can access your variables, you will give it as public. So once we see more examples, we'll be knowing, we will be seeing more of this. Okay. So similarly, we already saw the functions. So a member function of a class is a function that has its definition or its prototype with the class definition. Like whatever the function we have, like the more we'll see examples, we'll know about functions also. So access modifiers we discussed, the public, private, and protected. The other concept in the classes is constructor or destructor. So what is a constructor? A class constructor is a special function in a class that is called when a new object of the class is created. So when you say student S1, if you want something, when you say student S1, an object is getting created, right? So that is the time a constructor is getting called. So similarly, in the constructor level, if you want to assign something, you can still assign a few things there. And similarly, when you want to do something, when an object is getting deleted, you can call a destructor. So once we see more examples to this, we'll see more of this constructor, destructor, and these functions. So we will be in the initial classes, we'll be discussing about. Okay, so now we came to know about classes and objects. So in the OOP concept, the first concept is inheritance. So one of the main use of inheritance is code reusability, right? So in general programming, this is nothing to do with object-oriented programming, but it's became one of the concepts of object-oriented programming. So what is code reusability, right? Let's take a simple example of calculator. So if I have a function, two variables, int a comma int b, and the function will do a plus b, right? So if I am passing few variables, it will be returning just the value. So now I have a method called addition with int a comma int b, and it is returning a plus b as a value. Now that is one simple function for calculator, right? So in other place, if I want to do addition of two numbers, I don't need to write that same logic again, a plus b. As I already have a calculator class with addition function which takes input as a comma b, I can just reuse the same program. I can just reuse the same class and execute it. I may be doing some billing, but I don't need to rebuild the calculator or rebuild the addition method. I can just reuse the code, existing code, right? So that is what is code reusability. If every time when we are doing programming, we won't reinvent the wheel. If we already have the some existing code, we'll be reusing the same code and we'll be building the new components on top of it, right? So as the name suggests, inheritance is the process of forming a new class from an existing class. That is from the existing class called a base. So the existing class is called as base class, and the child class is called as a derived class. So in the real world example, assume parent and child, right? So here parent is, we are calling it as a base class, and child we are calling it as a derived class. So if it, in our real world also, whatever our parents earned the properties and everything, we are inherit the children of the parents of the family, they inherit the properties, right? So if your father has a house, we inherit the house, right? So similarly, if you derive a class from the base class, the advantage to the derived class is whatever the base class has the variables or properties or behavior, all those will be accessible to the derived class. So in other words, if if the parent has some functionality and variables, if the child class is derived out of the parent, then the child will automatically inherit all the properties. So, for example, in the base class, if you have a method called calculator, a class name called calculator, and if you have a method called addition, which takes input as int a comma int b, then the child class can automatically use that addition method. It doesn't need to rebuild that method because the child class will inherit the properties and methods of the parent class. Once we see more examples, we'll come to know about this inheritance. So, see, similarly, the overloading and overwriting. Go back to the. So, polymorphism. So, polymorphism is nothing but one method, but it gives different formats. So, it looks to the same, but it acts differently. So, in polymorphism, we have different we have the most widely used one of the concept in C++ is both polymorphism and encapsulation. So I think once we know more about, once we show that inheritance methods, you'll know more on this. So for example, when we have a addition method in base class, and if child is inheriting the base class, you can either directly use that addition method, or in the child class, you can again implement the same addition method. So if you want to use what parent gave you, you can directly use it. Or if you want to do yourself, you can rebuild it. So that is called as overriding. So the method name will be same, the definition of the method will be same, the return type will be same, the number of variables will be same, but the implementation will be different. So once we see more examples, it will be easy to understand. So So, I don't want to. It's already late for me. I'm ending here. So in the next class, I'll see what is the code block you guys are using. But go through this site. I'll be sending you. It's onlinegdb.com. It's very easy to execute the program. I don't know how is the code block. I'll even check on the code block. But I found this as very nice online compiler. You don't need to have any ID or anything in your local. All you need is just your browser. Open this and just start running your program. Right? It has a save feature. You can easily create a new file. You can run the file. If you want to debug the program, you can debug. I'll check on the code block also. So whatever IDE you guys are using, I'll try to use the same IDE. So any are you just let me go back here. So understanding this initial class and objects is very important. See, rest of the programming is about how you use arrays, how you use exception handling. It's all built on top of this. But if you understand what is the what is a class, what is an object, how you are able to relate this to your real world examples, that is the key for C++. Rest of them is all programming with arrays, for loops, breaks, and everything. So those are all programming how to learn. But to understand C++ and OOPs, these are very important. Anyone has any questions?
Hi guys, you can unmute yourself and you can ask any questions.
In the next classes, we will go more deep into all these concepts, and then I will before the class itself, I will send you a few examples so that you guys can run in your lab directly. I was told that you are sitting in your lab in front of the computers where you have the C++ compilers. So even you guys can run the programs. We'll start with simple programs just to print some statements, and then we'll do small one by one. We'll apply each concept one by one, like inheritance, polymorphism, overloading, overriding. So we'll apply each level, and you will be doing in your class the examples in the lab. If you have any suggestions, let Anjani know. So at least she'll tell. But once we see in the next class, you'll get more doubts because you will be doing in your lab the programs. So then you will have more questions definitely. Okay, guys. I know you are coming from holidays, so that's why I already told shift this class also, because everyone will be in the mood coming back from holidays. So that's why I didn't want to take a long class here. So this is very short and small. So from last week to this week, all we jumped to the new thing is only running the program and visualizing how each object will be assigned the memory. So how to map the real world to the object-oriented programming. Okay. Okay, Anjana. We are not able to.
I hope that, students, there is no questions. Students, there is any questions? Thank you so much.
Thank you. Bye, guys.